for a standard system, we know that Lagrangian is half m for a standard system. For example, half m x dot square minus v of x, right? So then L bar is going to be minus of L minus L with t becoming minus IU, with t equals to IU, right? So that is minus half m x dot, as we have seen, x dot is I times x bar dot. So this is I square with a minus 1 x bar dot square, then minus v of x bar. So this is, you see, half m x bar dot square plus v of x bar. And this is great. This is a positive definite quantity. So if you consider a configuration where it is, say, for example, x bar dot is equal to 0, and take take the minimum of vx bar, then that point is the minimum, is an extremum of the action, and that function x bar being constant and sitting at the bottom of the potential. So for any other function, this contribution for the extremum is 0, and this is the minimum value of the potential. So for any other functional form, you see this will be larger than that, and therefore the path integral will be damped, right? So therefore path integral is damped away from. Path integral is damped away from its extremum. Okay, so the i-epsilon prescription says, this is about Euclideanization. I-epsilon prescription. It says that add to the action a term in the real-time action. Add to the real-time action a term I epsilon over 2 x square of t. Then in that case, this matrix element will be integral dxi to f exponential I over h bar s of x minus epsilon over 2h bar integral dt ti to tf xt square. So this damping makes the integral well behaved. So take epsilon going to 0 limit. So you take you have defined with an epsilon. Finally, after calculations, after calculations, take limit epsilon to 0. Now let me discuss the measure, the issue of the measure, path integral. Measure. So recall the formula for path integral I to f exponential I by h bar s I of x is given by xf e to the power minus I by h bar h times tf minus ti I. Now this calculation is sensitive to definition of path integral measure. However, this is unambiguous in the original Schrödinger theory. So a direct calculation can fix the measure. So a direct calculation can fix path integral measure and the latter, the measure, remains same for all other physical systems continuously connected. Systems that are continuously connected through perturbations, say. Yeah, through perturbations. Okay. before I proceed, so what we will do is to um, so we shall find measure for harmonic oscillator by performing Schrödinger theory calculation for free particle. Because harmonic oscillator is connected to the free particle through a perturbative corrections, because harmonic oscillator potential can be continuously can be tuned and continuously sent to zero, and then it becomes a free particle. So if we can calculate the measure for free particle, we get the measure for harmonic oscillator. That's what the exercise we will do. But before proceeding to do that, let me give you a description of partition function in terms of path integral. So the partition function, which is given by, say, z is equal to sum over n e to the power minus I e n t over h bar, that is nothing but trace of the operator e to the power minus I over h bar h t. If you use positions basis, then the same can be written as minus infinity to plus infinity x e to the power minus I over h bar h t x. And then you can use path integral for this one, for the matrix element, which is given by integral dy e to the power I by h bar s of y, with the boundary condition that yi is equal to yf is equal to x, because both of them are x, the same value. The Euclidean version of this is that e to the power, so trace e to the power minus beta h can be calculated by using this formula. Now I'm writing Euclidean path integral y by bar I equal to y bar x exponential minus 1 over h bar s bar of y bar, where s bar of y bar is nothing but du 0 to h bar beta L bar. So what I have done is the initial ui, I have taken this to be 0, and uf is uf is given by so I have done a scaling such that it becomes h bar beta. So basically uf minus ui is h bar beta, and then I have chosen specific values of uf and ui. Right, because this beta is nothing but t T is basically Tf minus Ti. Yeah. Here, for example, here also it is dt. Ti could be set to 0, and Tf is basically T L. But then what I have done here is that I, T, H bar all together I've called that beta. So beta is I, T over H bar. So T is I times H bar beta, and therefore U should be H bar beta. This is what I've done. That is how you get it. Okay.